In this video, I want to go through a CFA Level 1 exam style question coming from the Quantitative Methods section of your curriculum. We're going to talk about mean absolute deviation, or MAD, and also a little bit about the range. So if this is something you want to get right in the exam, keep watching and let's get solving. So this is the question which I want us to have a go at. The table below provides the annual total returns for 5 individual client portfolios managed by Sunrise Capital over the past year. 5 portfolios and 5 returns observations. What are the range and mean absolute deviation, or MAD, of the portfolio returns? 3 options follow. Okay, let's start with the easy one. That's the range. We're going to get that out of the way relatively quickly. This will be basically the difference between the maximum value observed and the minimum value observed. Please note that the maximum value is going to be 3.5. However, the minimum value is a negative 2.6. So we're effectively deducting what is a minus 2.6, which equates to essentially adding this amount. Anyway, the range is going to be, 6.1%. Okay, and this very quickly takes us to the choice between answer A over here with a range of 6.1 and C with a range of 6.1. So it's going to be either A or C. Well, that was the easy one. Let's go for the second one. That's MAD, or mean absolute deviation. Right. This is going to be a little bit more difficult. What we're going to, let me write the definition in words, and then we'll get the formula down for this one. This is the arithmetic mean, so the average, basically, of the absolute deviations from the mean. Now, in a previous video, focusing on the properties of the arithmetic mean, the average, I showed you that if you sum all the deviations from the mean, the distances from the mean, you'll get a value of 0, a sum of 0. That's why here we're taking the absolute deviations from the mean. The formula for this is going to be the sum from observation number 1 all the way until observation n, whatever n may be. In this case, it would be 5, of the absolute distances of each observation from its mean. That's how we denote the mean. That's x bar divided by n. Okay. So, first of all, what is x bar? What is the mean here? Well, let's take all of these values and quickly see what that gives. I'm not going to show you this on my calculator. It's a relatively easy computation to do, computing the mean. Just take all the values, 2 plus 3.5 minus 0.5 plus 0.3 minus 2.6, divide by their number, so 5, and the mean, at least what my calculator is telling me, is 0.54%. Okay, brilliant. Now, let's get those absolute deviations. So I'm going to have to take each of the returns and see how far it is in absolute terms, so ignoring the negative sign potentially from the mean. Let's start with the first one. So the return over there was 2. The mean is 0.54, just computed this, and I want to get an idea of this absolute distance. So no need for the calculator here. It's going to be 1.46, isn't it? 1.46%. For the second portfolio, same thing, 3.5 this time, minus 0.54. Okay, what is this distance? Well, it is going to be 2.96%. For the third one, okay, now we've got a negative one, don't we? So it's going to be a negative 0.5 minus 0.54. And that would normally tell us the distance is, well, it's a negative 1.04, but because we're taking the absolute, we're eliminating the minus sign, and that becomes simply 104, doesn't it? And for the next one, we just need two more. So fourth one is 0.3 minus 0.54, and that gives a normally a negative 0.24. But once again, we eliminate the negative sign because this is absolute, so it's just 0.24. And the last one, the fifth one, that's the difference between negative 2.6 and negative 0.54. Once again, we eliminate or neutralize the negative sign, and this simply becomes 3.14. Let's sum these up, okay? And I'll need my calculator for this. 1.46 plus 2.96 plus 1.04 plus 0.24 plus 3.14. Okay, the total comes in at 8.84. Okay, this is all in percent. And over here, let's plug this into the top. 8.84%. Divide this by the number of observations, which was 5. Divide by 5. 1.768. Obviously percent. Okay, and I can see this is very much in line with our answer A over here. So the range agrees, 6.1. The MAD agrees, its answer, A.